Okay, here it asks for, in B, it asks for us to graph this data that we have for the function. It asks to graph f. So what we have to do is first get the critical values of f, not literally, but just important values. So its y-intercept we can see is -1. One of its zeros is at 1. At 2 it equals 2. At 3 it equals 0. So that's what we have for that, for the real function. And so this is pretty obvious, negative, positive, positive, negative. So we know it doesn't go up, it goes down there. But we need to take into consideration its derivatives, first derivative and second derivative. So from 0 to 1, its first derivative is positive, which means the function is increasing, but its second derivative is negative. So when the second derivative is negative, the function is concave down. So it's increasing concave down from 0 to 1. So we can draw something like that. And it has a 0, f prime is a 0 there. So here there's no slope. The slope is 0. So from 1 to 2, it's positive, and its first derivative is positive, and its second derivative is positive. So it's increasing concave up from 1 to 2. And at 2 equals 2, and its first derivative does not exist. So there's got to be some sudden change or some hole or something like that. So what we can do is from 2 to 3, the graph is positive. The f prime is negative, so it's decreasing. The function is decreasing, and its second derivative is negative, so it's concave down again. So there's a sudden change in concavity. So it sort of goes like that. And before I go further, at x equals 3, the first derivative is -3, so it's a constant. And the second derivative is 0, so because this is a constant, the derivative of a constant is 0. So we gotta do a constant at that part. And let's see it. F prime of x from 3 to 4 is negative, so it's decreasing, and its second derivative is positive, so it's concave up. So we can just go like that. And that's basically that's all you need to do, really.